Geometry 2-3 biconditionals and definitions. Okay, so it says each conditional statement, remember that's if then, is true. Write its converse. Converse is when you flip it. The converse is also true. Combine the statements into as a biconditional. Biconditional is when you add if and only if to the middle, and you take away if in the beginning and then in front of your conclusion. So we start out with if a number is divisible by 2, then the number is even. So we need to write the converse. Converse would be if the number is even, then it is divisible by 2. And that's true. Your biconditional, a number is divisible by 2 if and only if the number is even. So we take this, take away if, take away then, put if and only if in the middle. Okay, we're going to look at number 3. It says if x is greater than 5, then the absolute value of x is greater than 5. So we're going to write the converse. We're going to flip it. If we flip it, we have if the absolute value of x is greater than 5, then x is greater than 5. But that's not true, because if we use an example like -6, the absolute value of -6 is greater than 5, but -6 itself is not greater than 5. So we cannot write that as a biconditional. Number 6, write the two statements that form each biconditional. So you're just going to take this and this. You're going to put if and then in front of them, and then you're going to write the converse. So two lines are perpendicular if and only if they intersect to form 4 right angles. So you're going to take two lines are perpendicular, and you're going to take they intersect to form 4 right angles. You're going to write it one way, and then you're going to write it going the other way. So if two lines are perpendicular, then they intersect to form 4 right angles. You also have to have the converse of that. If two lines intersect to form 4 right angles, then they are perpendicular. Okay, number 10. Test each statement below to see if it's reversible. So if it's reversible, you're going to write the converse. If the converse is true, then it is reversible. And if it's reversible, you're going to write it as a biconditional. If it's not reversible, so it's not true when you write the converse, you're not going to write the biconditional. So number 10, if a quadrilateral is a square, then the quadrilateral has 4 congruent angles. So we need to write the converse of that. So we need to flip it. So the converse would be if a quadrilateral has 4 congruent angles, then it is a square. That's not reversible because it could also be a rectangle. Okay, number 11. An isosceles triangle is a triangle with 2 congruent angles. So if a triangle is isosceles, then it has 2 congruent angles. You can reverse that. If it has 2 congruent angles and it has isosceles, those are both true. So then you would just write the biconditional out of it. If a triangle has 2 congruent angles, then it is isosceles. So the biconditional would be a triangle is isosceles if and only if it has 2 congruent angles. Or, because remember the sides are also congruent in isosceles triangle, but it's because they're across from the angles. And then the other answers for the rest of them will be posted on your page.